Today's webinar, Corona Treater Maintenance, Top Tips, with a live Q&A session at the end of the presentation. This is Mark Plantier of Enercon Industries, and would like to thank you for your attendance today. This webinar is being recorded and will be made available to all of you as soon as it is posted on Enercon's website within the next few days. You may ask a question at any time during the webinar by typing it into the question tool provided on your screen. Our panelists will answer the questions at the end of the webinar. Our panelists today are Enercon Service Manager Matt Rajala and Enercon Vice President of Application Engineering Tom Gilbertson. Combined, they have over 35 years experience in corona treating applications. The program today will cover topics including why maintenance is important, safety tips, effects of corona treatment byproducts and environment, what happens when you don't maintain your system, and maintenance best practices and techniques. At the end, we'll have a question and answer session, and any question that we are unable to get to within the time frame of the webinar, we will follow up after the webinar with answers via email or with a phone call. With that, I would like to turn it over to Matt Rajala, who will begin by talking about why maintenance is so important to the corona treating process.
All right, thanks, Mark. Hi, this is Matt Rajala here, Service Manager with Enercon Industries, and I'd like to thank all of you out there for joining us today to go through this, and I trust that this will be helpful for you guys out there at your companies. And right away, this slide just kind of showing the 3 reasons why maintenance is most important. Number 1, you want to make sure that all your equipment on your production line is in tip-top shape. You want to make sure you're putting out, put out quality product. You want to make sure that your equipment on your lines are in good shape and good condition. So we're going to go over, a lot of maintenance checks that are going to be important to ensure that. Number 2, you want to make sure that, well, basically, reduce any replacement parts, reduce the way that you need to spend purchasing parts and everything for the system. So essentially, just maintenance is going to be good to extend the life of the components on your corona treater to ensure, the longest life possible. And number 3, the most important, is reduce unexpected downtime. You just want to make sure you want to keep your production running smoothly, and we'll talk about how to keep that going. So with the corona treaters, Respect Corona, it is a unique piece of equipment because it is putting out 10,000 volts. 10,000 volts is high voltage discharge, and that's what's essentially performing the work to functionalize your material on your line. So definitely something to keep in mind, but it's really more of a respect. It's safe, but yet you do gotta respect it, and we'll go through how to respect it. So again, safety first. Basically, anytime you're doing any adjustments or maintenance or cleaning on your corona treater, just like any other piece of equipment, you're going to want to make sure that all operators have been properly trained. As far as training goes, there's a lot of information in our manuals. If you don't have any manuals for your corona treater, feel free to contact us here at Enercon. We'll be happy to provide you any information. And most of that information is going to be in the manual. Also, prior to working on the system, make sure that you follow any, basically your lockout, tagout procedures at your facility to remove and isolate all power, incoming power going to the system at the power supply. And this picture just kind of shows a typical place to lock out and tag out that power at the power supply to basically just make sure everything is completely safe at the corona treater before you're doing any adjustments or maintenance or cleaning. So the corona treating system, again, we talk about it functionalizes the material for treatment, but it also is going to produce byproducts based on the environment and just the nature of high voltage discharge. This slide here shows the 2 main byproducts produced from the corona treating process. Basically, the high voltage discharge by nature is going to create ozone, and it also creates heat. First, we'll talk about ozone. The ways that the treater design helps mitigate the ozone is, as you see this picture, this shows our basically our efficient design of how the electrode assembly draws in the air to cool the electrodes, but also you see how it captures and removes the ozone from the treatment area. Again, just a natural byproduct of high voltage discharging through air. Similar to a lightning strike or even using the copy machine, you're going to have ozone created as a byproduct, and this just shows how our electrode assembly is designed to capture that ozone and draw it away from the process. And also heat. Heat's created, another byproduct of corona discharge. So our system is going to, and kind of from the last slide, you remember the air was moving across the surface of the electrodes, across the surface area to remove that heat that's created as a byproduct. And environment. One common question I get is, how often should I clean my corona treater? Well, our manual will state certain weekly checks or quarterly checks, but really it's going to depend primarily on the environment that it's in. I've seen some very extreme environments where there might be a lot of powder and stuff in the process, where it's gonna that exhaust system is gonna catch all that debris and everything in the environment. Where in the most extreme case, where they got to clean it every shift. Now again, that's very extreme, but again, it's going to depend heavily on the environment. But a good starting point is going to be weekly checks to just kind of see how your environment's going to react with the corona treater. And now we're going to talk about what happens when you don't maintain your corona treater. We're going to kind of go through some of the problems and really, most importantly, how easily that these problems can be prevented just by doing some quick cleaning. Just takes a couple minutes here and there. Visually, you can see dirt and grime. In this case, there's a ground roll covering, ceramic ground roll covering on the left side of the slide here that shows, and this was actually a roller that was sent back to Enercon, where they thought there was a problem. There was some arcing going on at the roll, and then we found that basically it was just surface grime in this case. And in fact, we're going to go through, there's some slides later on in this presentation where we clean that roll, and we're going to show you guys how to properly clean it, what type of cleaning agents to use, and that type of thing. So as heat and humidity increases, there can be a lot of underlying problems that become amplified when heat and humidity are present. Because what it is, you can think of it this way: the high voltage is going to look for the shortest path to ground, for example. And the reason I mention that is, there may be some high voltage wiring that's too close to ground, or things like that. And what happens is when you get moisture, well, moisture and dirt and debris don't mix very well with high voltage, because that high voltage is going to find a shorter path to ground and arc through that. And what I mean by that is, I mean that it's just going to create a spark, and it's going to lead to equipment damage for the most part. Shorten the life of the insulating shroud, shorten the life of electrodes and things like that.
So Matt, this is Tom. So Matt, really what we're talking about here is when we see a corona station that has a lot of debris that is collected on the electrode assembly or the ground roll, that debris is likely as a result of environment and material. So the corona treater will kick up oligomers and slip additives and different things from the material. It combines with humidity in the air and dirt in the air, and the combination of those things creates carbon. And folks, that's what Matt's talking about. When that carbon gets created, it's a better path to ground than the ground roll. And when that happens, ultimately, it puts stress on all the various electrical insulators, wires, so on and so forth. Those things ultimately will fail, thus causing some downtime. So the cleaning of a corona treater, without regard to the type of corona treater, the brand of corona treater, the size of the corona treater, none of that stuff makes any difference. Really, the main point Matt's making to everyone is the corona treater has to be kept clean.
Yep, very good, Tom. And kind of to follow up on Tom's point, that carbon, that form matter, and again, it doesn't matter what type of corona treater, it's just, a result of the natural process of that high voltage discharge. That carbon is going to become, with exposure to high voltage, electrically conductive and create a shorter path and lead to localized heating and things like that. So yeah, just quick checks, cleaning that carbon off with oil-free compressed air and things like that is just going to, go a long way. So now we're going to talk about the 3 most common maintenance mistakes. And these, a lot of times, it's kind of nice to summarize them in this manner. One is, not having a scheduled maintenance program. And, that is going to be something, again, it's important to, get production going and stuff, and you want to keep your lines going as smoothly as possible. But it is nice to kind of schedule, whether it's going to take it down from, having a problem or just taking it down at a scheduled time and kind of be proactive about it is always a good idea. Not cleaning in all the areas. And this one is what I find fascinating. It's most interesting. And this is what we try and help give as much information to all of you out there. Because I've seen a lot of customers in my days of field service. I've seen a lot of people who, they mean well, they do have a scheduled maintenance program in place, and they are doing the right motions, if you will. They're getting in there, they got rags, they got people, they're locking out the systems, they're cleaning everything, but they're just not getting the key areas, and that's what we're going to address in this webinar. And then also using the wrong cleaning techniques and the wrong cleaning material. And that's another thing, too, that we're going to discuss in detail. Again, where people mean well and they are, implementing a scheduled maintenance program, but just not using the correct materials to clean, which can lead to other problems, and we'll discuss that. So first we'll go ahead and start talking about, we'll focus on rolls. You remember that roll that we saw in that slide earlier that had all that debris on it and everything, which the customer thought was, a problem because there was arcing and stuff like that occurring. So here's an example of that, perfect example where you have a lot of surface debris. And what that is in this case, I mean, they might have had other things going on at the plant, but then you have that that darker brown strip on the right-hand side. What that, and that's going to, that can be common on corona treater ground rolls, because you'll see that basically as the material is passing through the treater station and you're corona treating the material, any slips or additives or anything in the material tends to migrate out towards the ends, and then it kind of leaves that residue on the corona treater. And we'll kind of go through some convenient methods to clean that up. So here's some typical ceramic cleansers. You see here a Comet, so that's kind of a starchy type of cleaning agent that you would mix with water, and it has a little bit of grit to it, and that's completely safe to use on ceramic. Also a Scotch-Brite pad, completely safe to use that on, when cleaning a ceramic covered ground roll. And then, a glove to just kind of put over your hand to keep that clean, and then a lint-free cloth. And something not shown here will be isopropyl alcohol. That's very prudent to use isopropyl alcohol after you're done cleaning the roll with your mild soaps and your ceramic cleansers, just to kind of give a final rinse to get any residue off the ground roll with isopropyl alcohol and dry it off before you use it. And then here's a picture of a use only non-metallic tools. In this case, that's kind of a ceramic bar, another ceramic strip that's being used to kind of scrape off that heavy debris. But never, ever use any files, no metallic items or anything like that, because that can leave little shards of metal in the ceramic, which again is going to lead to that localized heating and shorten the life of the ground roll. So,
and one of the things people may not account for in that description Matt just gave you is the use of steel wool. I've had customers go ahead and just go up there with a very fine steel wool thinking, well, it's the gauge is so fine, or it's a very mild abrasive, it's okay. Well, really the steel wool is probably the worst offender, because it is, because of its construction, easily it leaves behind little bits of metal and so forth. And as Matt pointed out earlier, the corona will always go to the path of least resistance. So if you leave any metal shards or little bits of fibers of metal on this roll surface, the corona is going to look at that metal as a better path to ground, and it'll light up, you know, kind of like a firework kind of view, and ultimately it will cause, long-term, it could cause the failure to that ceramic-coated roll.
Yep, and then here's a picture showing the, you know, a Scotch-Brite pad, for example. Again, no metallic, nothing conductive in that pad. It's just a scouring pad, but it's, you know, a Scotch-Brite with just polymer-based or whatnot, and using that to really scrub in that ceramic cleanser on the ground roll. And one thing I like to mention is, because a lot of people, rightfully so, they're afraid to, you know, hey, ceramic covered ground rolls, they're expensive, so they don't want to do anything to damage it or anything like that or jeopardize it. So when we talk about wrong methods of cleaning, what I'll notice a lot of times is, you know, people will not really scrub it the way they should. It's completely fine if you got, you know, a Scotch-Brite pad with some ceramic cleansers. A lot of times you'll be scrubbing it by hand enough to, you know, kind of get a little sweat on your forehead. That's going to be normal, and that's fine. So really put in some elbow grease to get that grime and stuff off the ceramic roll. There's nothing wrong with that. You're not going to damage the ground roll by doing that. So I just want to kind of throw that out there. That, you know, again, it's a healthy, you know, theory. Again, you don't want to damage it, but it's completely fine as long as you're using the right cleaning agents like Scotch-Brite pads and mild soaps and ceramic cleansers. Go ahead and scrub that, and it's going to be fine. And then, like we talked about, do a final wipe down with alcohol. You know, just to kind of take off any residue, any residual stuff that's on there from the cleaning agents you used, and make sure that that roll is completely dry and everything before you put it back into use, which isn't going to be a problem if you do a good wipe down with alcohol and let it sit for a couple minutes. So here's just kind of a picture showing before and after. And, you know, I will admit that, you know, this was kind of a best case scenario for this slide. A lot of times you will, you know, you're not going to get it perfectly clean, so I don't want people to stress out there if it's not completely 100% clean. But it is realistic, though, to think that, yeah, you can get most of that especially if there is grime or anything on your ground roll, to get that off with some elbow grease. And one thing, while we're talking about elbow grease, you only want to use elbow grease and just use it by hand. You don't want to use any motorized tools or anything like that to clean the ceramic ground rolls. So no buffer motors or anything like that. You know, it's all just clean by hand. So, and here's just some information for cleaning non-ceramic roll coverings. For example, if you have Hypalon, silicone, or epoxy, you can use mild soap and water is fine. You can use an alcohol rinse sparingly on silicone. So, for example, just put a little isopropyl alcohol on a rag and just kind of wipe it over the silicone. You don't want to squirt it directly onto the silicone, as it'll dry that out. So, but it's safe to use it sparingly, like so, just on a rag and then wipe down the silicone sleeve or vulcanized silicone roll. Aluminum rolls, if it's a bare aluminum roll, again, you can use mild soap and water. You can use a Scotch-Brite pad for oxidation. You can follow that up with a nice alcohol rinse. If there is a lot of oxidation, you can contact us. Sometimes you can do, you know, a small little surface cut if there's major oxidation that's causing any treatment concerns or treatment issues with backside treatment. You can certainly, you know, possibly do like a surface skin cut. But again, contact us here if you have any questions, just with your serial number. We can certainly help you out, decide what you need to do. And now we'll talk about preventive maintenance for the electrodes. So again, the neglected electrode assemblies, you know, can cause overheating of the electrodes, and we'll go through that in more detail. You know, a lot of it comes from that exhaust and environmental concerns. Again, kind of related to reduced ozone evacuation, and also high voltage arcing, again, from accumulation of, you know, just letting dirt or any debris accumulate in there and becoming conductive. So here's some pictures of neglected electrodes. You see kind of two different two different samples. One there's a little bit of junk and everything on the ceramic electrodes on the left. On the right side, it shows where, with our design, you can hinge open the electrode assembly to access the cooling air ports when you're performing maintenance, and you can clean that out pretty nicely in there. And again, here's just a slide kind of demonstrating that, the kind of the suction method of the electrode assemblies. Again, that design being to remove ozone and remove heat. But one thing to also consider is it is going to be drawing in anything from the ambient air. So depending on what the environment's like, that stuff is going to, there can be dirt and everything that accumulates on the cooling air ports. And here's just kind of a picture showing how we design it so you can easily hinge open that electrode assembly to clean out the cooling air ports. And again, these type of checks that we're going through is kind of meant to do, if they're done regularly, it's only going to take a few minutes. I'd say maybe 15, 20 minutes. It'll probably take more time just locking out and tagging out the equipment than actually doing the cleaning and checks and cleaning out the, for example, the electrode assemblies. You can, for light dust and dirt, just use a rag, a lint-free rag with isopropyl alcohol, mild soap. You can also use oil-free compressed air to just kind of blow that out, or a vacuum.
You also want to make sure, to Matt's point earlier about just sort of doing a surface prep, and I've seen this quite a bit over the years. People will take up an alcohol and a cloth and they wipe the surface of the electrode down, but they will not either remember, or some don't even realize that that electrode assembly has that hinge features that they can access the back of the electrode assembly. So it's really important that when you are taking the time to do this quick maintenance step, open the electrode assembly and take that same cloth and alcohol and wipe the back of the assembly off, because the mounting tabs of the electrodes, the mounting blocks of the electrodes are all accessible now, and you can clean those off, because that same dirt and debris that you see on the surface face of the electrode is likely also deposited on the mounting tab of the electrode and the mounting block of the electrode, and those parts have to be wiped down as well.
Thanks, Tom. And yeah, and following up on that point, when I mentioned earlier in this presentation about, customers not, having a well-planned maintenance schedule but not cleaning all the right areas. In fact, this image right here is the first image that pops in my head when I say that, because I'll see a lot of people who they mean well to clean the face of the electrodes, without hinging it open, but then they won't get in there and clean out the, like say, the brown insulating shroud that houses the electrodes. And again, it's just a quick, kind of blow that out with oil-free compressed air, a clean rag. But that's kind of the mental image I get in my mind when I think of people not cleaning all the right areas. I think that, yeah, they're, just not getting them back behind the electrodes. For ceramic electrode cleaning, a lot of the same principles for cleaning the ceramic ground roll apply also to the ceramic electrodes. Again, Scotch-Brite pad with any household abrasive cleaner. Again, any kit, it doesn't have to be anything elaborate, just any kitchen and bath type cleansers you have purchased from the store, from the hardware store and stuff, is going to be just fine. And then always do a final rinse with isopropyl alcohol. And then metal electrode cleaning, very similar. A lot of those are going to be whether you got fins or push segments. You want to use any type of metal cleaners to clean that isopropyl alcohol. You might need to kind of work the segments in and out to get any grime and dirt out of there, just to get some good free motion. And now we're just going to kind of briefly talk about electrode alignment. I think it's just fair to kind of mention this, because anytime you do maintenance, again, we kind of talk through the main guidelines of, number one, safety, lockout, tagout, then number two, doing the actual cleaning. Now, three, after you clean everything, since you were moving things around, it's not a bad idea to just double check the electrode alignment. Now, again, if everything is, assuming all the hardware was tight to begin with, you shouldn't need to readjust the gap, but since you were in there, performing maintenance and cleaning, it's going to be a good idea to just re-verify it before you put it back into production. This shows an example of a misadjusted electrode assembly, and then we'll kind of go through some of the procedures on how to get that back in line in a few slides. A misaligned electrode assembly can cause uneven treatment, provides inadequate treatment, it can also lead to electrode failure.
And the electrode failure Matt's referring to can be tied back to our conversation point earlier relative to the corona always going to the path of least electrical resistance. This is a common theme throughout this presentation, folks. So if you go back, if you can go back to that slide, Mark, where we show the misadjusted electrode. Yeah. So in this particular picture, the electrode that's on the right of that assembly is going to get more power to it than the electrode on the left side of the assembly. So if you have 5 kilowatts being dissipated on this electrode, and let's say they're both uniformly gapped, and each would then get 2,500 watts to them, when they're misaligned, one's going to see more than 2,500 watts than the other. And that's because the distance between that electrode and the ground is a lot shorter. So in addition to Matt's recent comment about poor treatment results, which are certainly also part of this, that electrode in this instance, that electrode will, if you leave it like this, it will likely overheat, and the overheating will cause a crack, and the crack will cause the treater to shut off. And so it's important that the electrode air gap is adjusted properly both up and down and side to side.
Yep, so then kind of discussing on making sure it is aligned then, because now we're kind of aware of some of the problems that can arise. What we want to do is we want to measure the air gap between the electrode and the ground roll on each side of the electrode, and we'll go through that in the next slide here. The other thing is the recommended air gap that we recommend is 60 thousandths of an inch, 1.5 millimeter. And it's not really necessarily a magical number. It's just basically what we found is 60 thousandths is wide enough to allow a majority of materials and applications to pass through the treater without any physical impact or anything. And yet also 60 thousandths is also narrow enough that we're not going to be putting any more undue stress on the high voltage wires, the electrodes, the insulating shroud, that type of thing. So, and then also, and the other thing too is it's a balancing act. I'm not looking for precision necessarily. I'm not looking, there's no tolerance per se. It doesn't matter if it's 52 thousandths or 60 thousandths. But really what we're looking for is just whatever the electrode gap is set to. Again, our recommendation is 60 thousandths, is to kind of try and make it as consistent as possible on all of the electrodes. Yep, and we do provide gap gauges that are 60 thousandths of an inch in thickness. And you can always contact, if you don't have any gap gauges, or maybe you did have some Enercon gap gauges and misplaced them, feel free to contact us and we'll be happy to send you some out. And then this slide just shows kind of some general gapping procedure information. So basically you see on the diagram on the left, figure 1, the end plate bolt is, if you need to make an adjustment up or down, so in other words, increase or decrease the total electrode gap of the electrode assembly, you'd want to loosen the end plate bolt, and then you actually turn the air gap adjustment bolt, and that's going to be with 6 millimeter hardware, Allen wrench. And so that's going to be kind of how you're going to increase or decrease the total overall gap, because as you see, when you adjust the air gap adjustment bolt, that whole end plate is going to float basically on the frame to bring that electrode in or out. And then there's also the stop bolt, which is shown in figure 2 there. The stop bolt can be adjusted in or out to adjust the pitch of the electrode assembly. If you remember from that slide a few slides back that showed a misadjusted electrode gap, that was actually due to the pitch or the tilt being off of the electrode assembly. So the stop bolt would be adjusted to adjust basically where that's going to stop as the electrode rotates open and closed. And and then basically the figure 3 is showing the electrode limit switch. We have an electrode limit switch, which is the switch roller on the left side there, figure 3, and that's going to fit in the notch, and basically that's the safety interlock. So if the electrode assembly pivots out out of the treat position, that electrode limit switch is going to stop the treater due to the interlock fault for safety. So that's another thing to, after you adjust the gap and everything, it's going to be a good idea to just double check that interlock and make sure it's functionally working. All right, and then the exhaust system, we'll just kind of go over some basic things of the exhaust system. That's something that a lot of people take for granted. Again, it's removing that heat and ozone, so it is very important, but it's usually something that's installed once and kind of left alone. But it is a good idea to periodically check the blower. Just make sure that the blower is rotating the correct direction in case electrical work takes place or whatever over the years. Also the duct work, inspect that. We recommend only using PVC or aluminum or stainless steel ducting, basically ducting that's going to be resistant to ozone. So galvanized ducting, you'll find that does corrode with ozone over the years. So you might want to just kind of go out there and inspect if you haven't thought about ever, just maybe go look at it and make sure it's not galvanized, make sure there's not big corrosion or anything going on in the exhaust duct. If there is, then it's galvanized, and we would recommend replacing it with something that's a little bit more ozone resistant. And then the exhaust specifications. Again, it's the importance of that exhaust system to help remove ozone and heat from the electrodes to extend the life of your equipment. Again, this is something that either people have never done or they do frequently, and a lot of people I find is they've never done this. So it might be a good idea to go out and measure your exhaust duct airflow and static pressure. The Magnet Helic is a differential pressure gauge shown on the left, which measures the static pressure. Most Corona treaters, wide web Corona treaters, the minimum static pressure is 12-inch water column. For narrow webs, it's about 7 or 8-inch water column. And then the airflow is going to depend on the type of, the size of the system and everything. And if you have any questions about the minimum exhaust specifications for your system, feel free to contact me here at Enercon with the system serial number. I can help you out with that.
All right, thank you, Matt, and thank you, Tom. Just to review the key learning points provided in the webinar today, the #1 way to increase the life of your electrode and rolls: start a preventative maintenance program. The 3 most common mistakes: know when to clean, what to clean, and how to clean. And the best practices to reduce scrap and increase productivity: properly maintain your systems, and you will produce reliable surface treatment and product. Here are some of the resources that are always available to you from Enercon: our emergency service support, 24-hour phone support, field service and field startup assistance, field equipment audits. You can dial the 262-255-6070 number 24 hours a day and connect to our service department. You can use the service@enerconmail.com to reach them directly as well. Many of the resources shared today are also available on our website, and certainly Matt and Tom are always available to you should you have any service or application issues. With that, we're going to begin addressing some of the questions that have come in.
Okay, Mark, this is Tom. The first question, really interesting one, it was posted about the relative humidity and dew point and when does it start causing trouble. Well, we've never done a study to actually pull up an exact data point, but I can say this. Clearly in the summertime, when dew points and humidity levels tend to be higher than in the wintertime, we definitely see an increase in issues relative to arcing, carbon tracking, dirt buildup. Basically, the treaters need more maintenance and more attention typically in the summer months than they do in the winter months. So I know it's a general answer to the question, but that's typically how that works. Another question came in about glass rolls. Do they clean easier than ceramic rolls? Now, I don't know if they clean necessarily easier. I will say that a glass roll in general is going to have a less surface porosity. So it still may be as difficult to clean when you have to clean it. It just may take a little longer for that roll to build up dirt and debris, just simply because the surface is different. But you can clean them both the same way. You use a non-corrosive, non-caustic cleaner, again a Scotch-Brite pad or some fine grit abrasive material, and rinse it off with an alcohol pad. Relative to those Scotch-Brite pads, we had another question about what type. They're mild and they're medium and they're very abrasive. Really, whatever the job requires. As Matt indicated earlier, you really can't damage a ceramic roll with this pad without regard to which one you pick, as long as you're using it by hand. We don't recommend you put it on the end of a drill or a belt sander or something and try to clean the roll that way, because that could potentially cause some damage. So as long as you're doing it by hand, whatever Scotch-Brite pad works the best for the amount of debris that's on the surface.
Yep, and then we have another question, going back to that relative humidity question that we talked about before. Someone asked if a relative humidity of 20% at 70 degrees Fahrenheit would be a problem, or if it would cause any operational problems. One thing, and as Tom mentioned, we haven't necessarily done any specific studies on it or not, but the spec in the manual is 80% relative humidity at 104 degrees Fahrenheit. So anything below that should be fine. Now, again, with that in mind is, again, during summer times or, whatever other type of ambient changes are or the type of material treated, there might be some, treater humidity or, juice and stuff like that that needs to be cleaned out. So keep an eye on it, but just kind of as throwing it out there, 80% relative humidity at 104 degrees Fahrenheit is what's stated, and anything below that should be fine.
Along the same lines, Matt, another point came up here relative to, again, exhausting and moisture and so forth. In order to keep that treater clean and to try to keep the plenum and the rest of the components of the treater from corroding, we recommend that the Corona treater ductwork is designed in a way so that when you come out of the treater, exhaust end of the treater, you put a T there rather than an elbow. And if you put a T there, you're going to create a drip leg for that exhaust duct. So if you get any moisture in that exhaust duct, it's not going to run back into the Corona treater station. Rather, it's going to run into that drip leg, where you can then have an access point to clean it out and to keep that moisture from getting into the end of the treater system. So that's, again, another thing. If you're looking at your ductwork and maybe there has to be some changes made to it anyway, that would be a very good change to make in the event you don't have a T at the end of the treater station. Matt?
All right, yeah. And then someone else asked, what is the maximum electrode gap that you can set the system to? Again, kind of going back to the standard recommended electrode gap is 60 thousandths of an inch. We don't have necessarily a minimum or maximum, but just kind of from a service perspective, what I've seen is, once you start creeping up, the higher the electrode gap gets, the more stress you're going to be putting on other components or, other things inside the station. So if you start getting up to about 100 thousandths of an inch gap, that's where you start to cross that line of possibly causing other stress, especially if there's, and again, it's going to be dependent on the condition of the system. If there's more moisture, you might get more arcing elsewhere and stuff in the system. So you want to keep it as close as possible at 60 thousandths, but in my experience, you don't really start running into more problems until you start creeping up to the 80, 90, 100 thousandths and beyond.
Matt, just one final point to add to your comment. Matt's absolutely correct in terms of the width. In terms of the tightening of the air gap, making it closer to the ground roll, again, generally not a problem, but it does make sense not to overdo that for two reasons. First, you don't want to do any damage to the electrode, but secondarily, if you make the gap too tight, you're going to restrict the amount of airflow going through the electrode assembly, and therefore you may inadvertently cause ozone to get out into the workspace or the web to hit the electrode or something like that. So I think if you stay with the general guidance that we have in terms of air gap overall, I think you'll be fine. Moving on, we got a very good question about treating aluminum foil web, and this is something that Enercon treaters are capable of doing. It's a benefit that those of you who have our equipment, most of you are able to treat both conductive and non-conductive webs. So with that said, the question is, would an aluminum foil web eventually cause any hot spots due to buildup over time? Well, the foil web itself wouldn't, but what happens with what we're doing when we treat aluminum foil is we're removing residual rolling oil from the surface. That's really what the treater's doing. That rolling oil has got to go somewhere. So we vaporize it with the Corona process, and we suck it up into the electrode assembly and into the exhaust duct. And so as a byproduct of that, that material can precipitate on the electrodes and on the mounting blocks and then the electrode tab area and so forth, and in the shroud area of the electrode assembly. And as Matt pointed out earlier, you know, if you wipe that stuff off before it gets carbonizes, it's not a problem. If you let those components ultimately carbonize with that oily residue, it's going to turn to carbon, and then you'll have high voltage tripping and arcing, and the treater will cause you some trouble. So really, just cleaning that material off is a recommended way to go, and it keeps the treater running smoothly and for a long time.
Yep. And then we got another good question here. It says, any special notes for double-sided treaters? Now, you know, there could be a few different questions springing up from this, but one thing that I want to just kind of address with double-sided treaters, it's always a good idea to, if at all possible, have one power supply driving each side. Kind of going back to the electrode gapping that we talked about, how everything's kind of a balancing act. If you have, for example, one power supply powering two sides of a treater station, what can happen is sometimes you'll get disproportionate power, you know, a little bit higher power or lower power on either side of the material, and you don't have that control of the power on each side. So on a double-sided treater, I would recommend having, you know, one power supply per side, so that way you can have independent control and you don't have that not as many concerns with the electrode gap imbalance issues.
Matt, we have another really good question about ozone smell and you know, what happens if they smell some. The odor from ozone from a Corona treater can come from various sources, and so here's a list of things for you guys to check. First of all, make sure that there's no leaking at the exhaust duct or the fan itself. Keep in mind, ozone is a heavier molecule than air, so if you have a leak in your exhaust duct, or you have seals in the fan housing, for example, if the fan is located near the treater, and it could be leaking, that leaking ozone is going to drop to the floor, and so therefore the people that work around the equipment are going to smell it. Secondarily, some materials tend to grab an ozone molecule and hang on to it. So for example, if you're treating a paper web, or you're treating, say, a nylon or polyester web, sometimes those products like that ozone molecule and they don't want to give it up. And how you can determine that is when you go to the winder of that piece of equipment, many times you'll actually smell ozone at the winder. Now, just because you smell it doesn't necessarily mean it's bad. Ozone is a very reactive molecule, and it's very pungent in its odor. So not much of it, you know, you don't have to have a lot of it present, and you're going to notice it. It's going to smell. And if you think about it, stand in front of a copying machine sometime and run like 10 copies at the same time, and you're going to smell ozone. This is just the nature of what this particular material is. So what you want to do is, you know, check your exhaust duct, check to make sure that the exhaust ports on the electrode assemblies are clean and free, and you're able to freely exhaust the ozone-laden air. And then if you still have concerns, get an ozone detector. You know, actually buy a monitor, stick the monitor in the area in question, and measure the amount of ozone. This is not something you can guess at. Nobody's got a calibrated nose. If you really feel that there's a problem or you have complaints from operators or personnel around the equipment, really the best approach to do then is to measure it. Measure it, get a number, and then contact Matt or our Enercon service department, and we can give you some advice from there once we understand what the problem actually is.
And kind of following up on some of Tom's points, because that is a very good question and a question we get from time to time. If you're smelling ozone in the working area, you know, the first place to kind of check is where that ozone is coming from. Tom mentioned how, you know, some materials might lock in that ozone, but something else too to check right away is, you know, the static pressure of the treater station. See if you are pulling a 12-inch water column at the treater station. If you are, for the most part, that ozone is most likely being trapped and carried out. So then I'm starting to suspect that, you know, either it's a leak on the positive side of the exhaust system after the blower, or what we've seen also, and this does happen more common than you think, is that ozone is actually being pushed out of the facility and coming back into the working area through fresh air intakes in the facility. So just some things to kind of keep in mind or watch out for. That's especially if there's a strong smell. I'm starting to suspect that, you know, it might be pushed back into the facility. So
Well, I want to tell you, you guys have asked some great questions here. I got another one. It's a really good question, and it's one that we answer regularly. The question is this: are there any problems with the web width being shorter or much shorter than the Corona electrode width? Would this cause more wear on the ceramic roll? This question can be answered two different ways. If the electrode in question is a ceramic electrode, where it's a fixed width and it can't be adjusted, and if you happen to have a universal treater where you have a ceramic-coated ground roll, the answer to the question is no. The discharge over that ceramic roll with the universal roll and ceramic electrodes, that roll is not going to suffer any particular impairment relative to the discharge being on it. Now, on the other hand, if the question is phrased this way, if it is a metal electrode and we have a ceramic-coated roll, or for that matter, any insulated roll, and we're discharging a metal electrode onto that surface, then in that case, it is possible that over an extended period of time that that area of the roll could wear out a little faster, and it's not something that will happen immediately by any means, but over a long term, it may shorten the life of that insulated roll.
All right, and then there's another question here just asking what the low limits of exhaust air flows before problems will occur. And again, that's going to depend, that's going to be station specific because every treater station is going to have a minimum recommendation for exhaust airflow and static pressure. So if there's any questions about that, again, if you get that equipment serial number found on the red and white Enercon rating plate, I'll be glad to answer any of those questions for your specific system.
All right. Thanks, Tom. Thanks, Matt. And thank you to our audience for your questions and your attendance today. Once again, everyone who registered for the webinar will be receiving a link to access the recording of the webinar as well as a PDF of the presentation slides. That should be available within a few days. Again, on our website, you'll find other webinars on related topics such as best practices for installing Corona treaters, as well as webinars on application-specific printing, coating, laminating, and alike. Once again, thank you for attending today, and this will conclude today's webinar.